Hey everybody, welcome back. So today we're going to talk a little bit about grids. Kluster uses the Bathy grid module. You can see here it's listed in the about screen. To take your soundings that you have georeferenced locations and depths for, and to build a grid, a 2D representation of those soundings. To do that, what you do is you select your converted data that's already processed, and you go to process new surface, and you're going to get this screen. So first we're going to start with the single resolution grid. So this grid has little cells that occupy the points that have a depth value for each cell, and all those cells are going to be the same size. And you can see down here we can pick the size of the cells, or you can leave it at auto and it's going to find the right cell size for the depth that you have here. These other things are going to be the size of the tiles that contain those cells, and the resolution, which we talked about. So the tiles, it's a bit of a thing. In the future, I hope to have a better system that recommends what tile size to pick. The basic idea is that you want to have a number of tiles, not just a couple. Something along the lines of like 20 at least, something like that. This is in meters, and you can see that our area here is something like 5,000 meters square. So for us, I'm just going to pick a tile size of, say, 256. And you'll see in the notes here, it says, if you have a small survey area, you might want to lower this to improve your performance. And then we'll process in parallel, which should make it go faster, assuming you don't have any memory issues. Okay, so enough talking. We'll just kick this off. So it's going to add the points to the grid, and then for each tile, it's going to create that gridded value. It's going to grid gridded depth and uncertainty values. And then when it finishes, you'll get a new entry here under surfaces. And you'll also see there's a new folder. Right, here's my converted multi-beam data, and here's the gridded folder. By default, it just puts it right next to the multi-beam data. Okay, so we have our gridded folder, and if I check one of these layers, you're going to see, I'll clear that out, you'll see the grid that follows that line. Right, so these are all these soundings, and then what you're seeing here in the map view is the grid. So if I query sorry, that's not what I meant to do. If I if I do the 3D points selection, you'll see right on the right we have the soundings, which are all the little dots right in space with the depth value, and on the left you see the 2D representation. So that's the point of the grid. It gives you a nice 2D representation, and you can go in here and you can export that surface, say, to a GeoTIFF, right? And then out here you'll get a GeoTIFF, and you can load this in other software to get an idea of the surface. So that's the basic gist of it. The other thing I was going to mention, since we talked about tiles, if you look inside, there's this root folder, and inside the root folder are all the folders for your tiles. So here we have 109, and remember we made, I'll have to go back and check myself, you can click and get the attribution down here. You can see we made 108 tiles, and the tile size is 256 meters. So there's that many tiles in there. So that's great and all. There's another option, which might even be of interest here because we have this change in depth. What if we created a surface? Let me get back to the screen. Here, I'll turn this off. What if we created a surface with variable resolution? So now, I'll go ahead and kick this off. So now we're going to take the same data and we're going to say, okay, pick the right resolution for each tile. And the advantage to that is if you have this change in depth like we saw here in this area that I have up, It could pick a finer resolution to give you better detail in shallower areas, or it could pick a coarser resolution to give you less detail in deeper areas. So that also might take a little bit longer. Oh, there it is. Depending. Okay, so now I've loaded my VR layer. You see it just loads right next to it. Right, here's our VR tile folder. So if I zoom in here, what you'll see is kind of interesting. Here in the top, and I'll turn the query on, you can see that we have 16 meter resolution, and then down here we have 8 meter resolution. I'll just click in here. And you can see this cells are smaller too. So what this means is down in here, we might get better detail, where if I go back to the single res, it's blockier. So this could be interesting if you're in a shallower area and you want more detail. And that's the basic idea of a variable resolution surface. There are some problems with variable resolution. In fact, there's a lot of problems. But the main one that you'll see as a user is if you're trying to do something like export a VR grid to something like a GeoTIFF, you end up with 1 per resolution, which may or may not be ideal. But that's something to keep in mind with the VR grids. Also, if you go into VR grids, you'll see that tiles have tiles, so it's a little bit more of a complex system that might be a little bit more fragile in the future. Although ideally, that you shouldn't have any issues with variable resolution surfaces in Kluster. Okay, and that's my my spiel on grids. Thanks for watching.